Hello, guys. Welcome back to Maths Zone African Motives. We are still on our mathematics and six, still working with the center of pressure. We want to see how is it different questions that we're given. All right, this is April 2023 exam that we are going to focus on, and I explained much about this. So if you want to understand, I want you to watch the video on the members. Make sure that you join the members so that you'll be able to watch that video. I explained a lot there that you need to understand. If you're someone who is still having that that problem, okay, you can watch the video which is there that can actually help you a lot. But anyways, I'm gonna try by all means also to explain in this video so that all of us will be able to understand. We are given 5.41, the top of a vertical retaining wall. Take note, the top, that is the one that we're talking about there, okay, is in the form of a parabola. We're talking about a parabola. Remember from our graphs, all right? This is a parabola, okay? Something of this nature, something of this nature, something of this nature. That's a parabola, okay? That's what we know about this. So we're given that it's in the form of a parabola and 6 meters wide. Okay, take note, 6 meters wide, meaning to say if I've got a parabola like this, the width, like how wide this is from this point to this point. So it's 6 meters wide. Okay, guys. Okay. This part, you wonder why do I explain like this? I want you to understand this topic, especially this part. These marks, you have them, these ones, 12 marks, these ones, they are yours in exam. They are yours for each and every exam that you might think of if you understand the way that I'm explaining right now. So we are given that it is a parabola, okay? That's the shape that you have. Always, as for me, I use the water level, the x-axis as my water level. I'm going to explain later on, but I want us to understand this. Okay, this is our retaining wall, like of the tank, okay? We're talking maybe of a tank, okay? Don't worry about that. Let's move on. This is it here. And 4 meters deep. What is 4 meters deep? The tank that we are talking about, or this part of the retaining wall. So we are given that 6 meters, but as it goes down, it is deep. The depth, you are going down. That's depth, right? The height. So we're given the depth there. It is what? It is 4 meters deep. Okay? That's what we have there. Now, the most important part. Then all this part here, all this part that we have been reading about the tank, about whatever that we're talking about, all this part here, it did not end there. They are giving us a comma there to mean it's a continuation of this thing that we've been talking about, the retaining wall that we had. It is what? 2 meters below the water surface. It is 2 meters below. So meaning to say this tank that we see here, it is 2 meters below. Okay, if it is 2 meters below, it's like this, all right? Because here definitely going to sketch this and that. We represent our strip that we're going to use for the area moment. I'm going to talk about that, the relation between the two variables, x and y. I'm going to talk about that. But I want us to understand this, all right? Like I said, as for me, I use the x-axis as the water level. So what it means is that, all right, this is 5.41. I'm going to have something like this. All right, last time I ended up drawing with that thing and now it ended up giving me problems. Let me just use freehand. I just hope you guys, you understand, of which are N6 guys, you're adults. You understand what I'm trying to do here. All right, so this is my X and Y axis, which is my Cartesian plan. All right, so I'm just going to go a little bit deeper, a little bit down. That's deeper. Okay, like this. So this is what we have. According to the measurements that we're supposed to have here, this was supposed to be 0, -1, -2, -3, -4, -5, -6, -7, and so on and so on. All right, this is what we're supposed to have in actual sense. I just want to explain about this. They are saying this here, since I talked about the tank that we're going to have, and I said, as for me, I'm going to take the x-axis as my water level. So I'm going to have this x-axis. This is our x-axis. So that is the one that I'm going to use as my water level. So that's going to be my water level. Okay. Now let's understand here. They are saying all this that we have been reading about this tank that we had, it is 2 meters below the water surface, which I'm referring as the water level. So we can just say this is a water level or water surface. All right. According to what we are given there, they gave us as surface, which is one and the same thing. Okay, no problem. This is it here. The question is, they are saying it is 2 meters deep. It is, it is 2 meters below, not 2 meters deep. It is 2 meters below. This is it. We have got 0, 1, 2, -1. We are going down. That is below. Below this, below your water surface, below this. So it is going down. All right? So if it is going down, it means I'm going to have this one, the shape here. Remember what we have here. We are going to take this as it is. 6 meters this side, 4 meters down. All right. So this is what we have. It is at -2 like this. All right. We're going to have our parabola. Remember our parabola shape. Okay. Like this. So it is passing at what? At -2 because it is 2 meters deep. That is the depth going down. I mean, no, not 2, I mean 2 meters from the water surface that is below, 2 meters below. Okay. I wonder why am I keeping on repeating this deep. I want you to understand this. We have got a parabola that we had here. All right. We have got its base, this one, which we are told about that it is 6 meters. All right. We are not worried about that. We know that 6 meters, this is going to be divided into 2 equal parts. I explained about that. From this side, it is going to be 3 meters. From this side, it is going to be 3 meters, but it will be a negative because we are going to the one to the left, but being 3 meters. So the question is, if we were to draw this parabola now to finish up, because we are supposed to have the shape of a parabola like this. This is what we are supposed. Are we going to have the shape of a parabola passing through -7 or what? Where are we going to have this shape of a parabola passing through? That is the question. That is the question then. Where are we going to have this passing through? That is the question. This is it now. We are given that it is what? 4 meters deep. 4 meters deep. So this is the one that we indicated here. This is the one for the wall or for the dam or for whatever, maybe for the container that you're working with. It is what? 4 meters deep. So if we are to take a consideration, as we just want to take this shape as it is. So meaning to say, from this base that we are given here, at this point, from this point, we are supposed to go down 4 meters deep. So it's going to be at -2. That is where we are. So we're going to go 4 units. That is 1, 2, 3, 4. So you're going to end up at what? At -6. So it's simply -2. Then the depth, which is 4 meters, is going to subtract -4. So it will end up at what? At -6. So meaning to say, as we are to have our parabola, we were supposed to have our parabola this way, passing through -6, going to this point, going back to the what? To the x-axis. But as we know that the diagram here is like this, this is the shape that we had there. It's like this. This is the actual shape that we have here. This one, here, this one. This is actual shape that we have there. All right? This is the actual shape that we have, but we are not supposed to have it that way because it is supposed to touch also the x-axis. So we are going to just draw this way from the x-axis to this point. Now we indicate at this point to say this is the exact shape that we want. So it's going to be a continuation like that. At -6, it goes back. All right, this is a parabola, guys. It's not supposed to be like a rectangle. It's a parabola. Sorry for that. So that's our parabola. Sorry for the shape, guys, but it just hope you understand the shape that I'm trying to have. That's a parabola up to this point. All right. Even if you use continuous lines, all right. If you even use continuous, I'm not saying it's wrong to use the continuous lines. No, it's correct. What is important is that, do you understand? Right. That is the most important part. Do you understand what it means or the representation of what we have here? In the previous case, I worked with an isosceles triangle, the one that I was talking about on the members video. Now it's a parabola. The idea is not going to change, no? Which idea are we talking about? To have the relationship between x and y, that idea is not going to change. All right, so this is it. Let us just save our strip. I'm just going to finish up now, because why do I spend time on the diagram? If you don't understand this diagram, then it's a waste of time for you to answer the question, because wrong diagram means everything is wrong. All right, so this is it here. We're going to have our representative strip with respect to what? With respect to y. Why do we take this? I explained in the previous class that it is because of the limits that we are using. The limits here are for what? For y. So like I said, if you're talking about area, remember on our integration, when you're just talking about area, volume, all right? Even from our N5, as long you're talking about area, the strip that you use is determined from the limits that you are given, all right? A to B for X, representative strip for X. If you're using the strip for Y, it is because the limits that you're given there are for Y. So if you check, we've got the limits for Y, all right? And we're going to use those limits for Y that we have, as you can see, all right? And also the other thing that you're going to talk about is on the area. The area moment that you're talking about here is the area moment about the X. It's referred as the first area moment. So as we know that for the first area moment for X, we talked about area moment, it is going to be given by an integration that talks about the distance from the x-axis, which is our y, from the from the x-axis. So that means definitely, as we long are talking about y, the integration there is supposed to be done with respect to y. Definitely later on, I'm going to talk about this formula later on. We are going to have with respect to y. So that's why I'm saying your strip is supposed to be for y, but I explained that. I think by now you understand this, guys. All right. Anyways, this is what we have. So the distance taken from the x-axis is going to be presented as what? As y. That is this y here is just the distance that we are talking about from the x-axis, since our area moment is about the x-axis that you're going to have at the end. So on your diagram, because you are going to need this, all right? So if you take here, all right, because before you talk about this, if you take here, it must make sense that we have got 4 meters here in between -6 and -2. Our bend units are there. There are 4 units. You can subtract -6 minus -2. You get what we have, or -2 minus -6. If you get a negative, if you get a positive, it's fine. What is important is that we need the number 4. All right. So you can even prove that, yeah, you're supposed to get exactly. So do not confuse this. All right. And also do not consider this part above. We are working with this part below. That is why I use dotted lines. We are not working with this part. That is why I'm not even worried about knowing this or worried about having this, because it's not part of what we have there. It's not ending where it's not full of water. I mean, it's not at the water surface, but it is 2 meters below the water surface. Okay. So the question is, calculate the relation between the two variables x and y. We need the relationship. So the relationship taken between x and y, definitely we need the equation of the function that we're talking about. This is a parabola. So we are going to take advantage of the points which are visible on our parabola. There's a point here where if you take this distance, remember from this point up to this point is 3 units, meaning to say we're talking about the x values. The distance going this side horizontal, x is 3, and y from this point up to this point going down at this point, that is what? -2. So the value of y there is -2. It's a point, 3 minus 2. Then also there's an advantage of this point on the y-axis, which is at -6, as we know that in the y-axis, x is equal to 0. So x is equal to 0, and the value of y there is what? Is -6. So we have a point, and a point. These 2 points are enough to have the equation. And also on your relationship, I explained that you are going to obtain this relation that you are going to have. It must be found for x in terms of y. Let me put it this way here. This relation that you are going to have, it must be for x in terms of y. Why that? Why so? Why x in terms of y? Why are we supposed to make x the subject? It is because, guys, these are applications of integration. We know what is going to happen later on. Later on, we are going to integrate. Isn't it? We are going to integrate later on to find the area moment. Integrating with respect to what? With respect to y. So as long we are integrating with respect to y, it means we must have our expression of x in terms of y so that you will be able to integrate an expression that is in terms of what? That is in terms of y. All right, with respect to y. So that's why I'm saying the relationship is supposed to be x in terms of y. That one, we shall see it later on, but we need the equation. Remember the equation of a parabola. If you are given a parabola like this, it is symmetrical to the what? It is symmetrical to the y-axis here is the line of symmetry. So symmetrical to the y-axis, whereby for this type of a function, I want you to take note for this one. This point is your minimum point, your minimum turning point. So on that type of equation, its equation is given as y is equal to ax squared plus or minus c. All right, if it is on top, it is going to be a plus. If it is down, it is going to be a minus c. Take note, we are not going to have that formula that we are used to. Y is equal to ax squared plus bx plus c. That one, it's on a condition whereby your function is got another turning. Maybe it is like this. The turning point is not along the x-axis, along the y-axis. If your turning point is on the y-axis like this, that it is a turning point or direct on the y-axis, the format changes, it becomes this. All right. I hope that was our N3 and N3 and 2. I still remember that, but for just a recap. So I think, okay, that's a recap for you guys. So the C is the y-intercept. So therefore, y is equal to ax squared. The C here, which is the y-intercept, our graph, it passes the y-axis where we have our turning point and also being the y-intercept at the same time. On that condition, if you have this condition where the turning point is also the y-intercept, you have your equation in this format. So it's going to be ax squared minus 6. The value of y there is what? Minus 6. So what we need is to find the value of a. From where? To find the value of a, that's where we take advantage of the other point that we are given. We've got another point here, 3 minus 2. So we have got the x value at 3 minus 2. We have got the x value, the y value. So that is the value of y there is what? Minus 2. So minus 2 is equal to a times x, whereby our x is 3. So that's going to be 3 squared minus 6. So there we have to find the value of a. It's an equation, guys, that you're supposed to simply solve. In this case, transpose minus 6 to this side, it becomes a positive. All right, that's minus 2 plus 6, which is a 4, is equal to 3 squared. That is 9. So we've got 9a divided by 9 by 9. So a is equal to 4 over 9. So if we have our a as 4 over 9, so therefore we're just going to substitute. Therefore, y is equal to a, which is 4 over 9 x squared. So we've got 4 over 9 x squared minus 6. Okay, that's it. In an actual manner, guys, I don't want to lie. This is where we're supposed to end. We have got a relationship there. It's a relationship. It's an equation. But because of what is going to happen later on there, because you are someone who knows what is going to happen later on there, that is where I said you are supposed to have x in terms of what? X in terms of y, because we are supposed to integrate with respect to y. If we live like this, it means our integration is supposed to be done in terms of what? In terms of x. And it's impossible because this is with respect to y. Remember, this is not volume where we talk about shell method. This is area. Area, we don't have that. A representative strip for x, area for x, limits for x. That's it. So if we want an area with respect to y, we must have expression in terms of what? In terms of y. So you're going to have x in terms of y. So you're going to make x the subject here. That's y plus 6. We transpose minus 6 to that side is going to be a plus, is equal to 4 over 9 x squared. So since I want the value of x there, what am I going to do? I can cross multiply. I can cross multiply, which is fine. Okay, you can do that. You can just cross multiply by this, or just divide, which is fine. Let us just divide, all right? Just divide, which is going to be easier. Divide by 4 over 9 here. Divide by 4 over 9 here. This will cancel. So therefore, x squared is going to be equal to 1 divided 4 over 9 is going to give us what? If you divide 1 by 4 over 9, it's going to be 9 over 4. So this will be 1 here, guys, divided to 4 over 9. It gives you 9 over 4. All right. So that will be 9 over 4 into what? Into this expression. So it's going to be into y plus 6, because we still have an expression there which is supposed to be done or to be simplified. But is it what we want? No, we want x, not x squared. What about x? So x is going to be the square root. The square root of this, that will be our x. So x is equal to, don't we know the square root of 9 over 4? We know this. The square root of 9 over 4, the square root of 9 is 3. The square root of 4 is 2. But we do not know the square root of y plus 6. It's an expression, that one. So you can't determine the square root of y plus 6. So it's just going to remain like that. That's it. X is the subject of the formula, isn't it? That's what we want. X is the subject of the formula. That's what they're asking here. When they're saying you're supposed to have a relationship between x and y. Don't worry about these 3 marks, guys. These guys, they mark 1, 1, 1, 1, 1. It's like a half, because this question, when it is 3 marks like this, when it is being marked, they mark it out of 6. This one out of 8, this one out of 10. That's how they mark your finals. They will divide everything, meaning to say the whole paper is out of 200. Whatever that you get, they divide by 2. So if you get 90, divide by 2. If you get 100, divide by 2. That will be 50%. So that's how. So meaning to say, imagine if this is 6 marks, maybe there's a mark here. So show all the working. That is for you to obtain those 3 marks that you're seeing there, because it is going to be divided later on. But they don't show that. All right, they don't show that. So the normal mark for our paper, it's out of 200. I don't want to lie. That is the normal mark. It is out of 200. Okay, anyways, guys, this is another part for another class. But someone will be surprised. Why are you taking a lot of time just to do this? No, guys, it's 6 marks there. But they don't put it in that way. They want you to, okay, to just normalize the abnormal. Okay, this is what we have here. Calculate by using integration. We are told there, using integration, of which you're supposed to know that you're supposed to use integration to calculate what? The area moment of the retaining wall. Which is our retaining wall? Our retaining wall is this one. This is the wall that we are talking about, this one. This is our retaining wall, the one that we calculated its relationship. So they need us now to calculate the area moment, all right, about the water level in question 5.0, about the condition that we are given, which is 2 meters below the water level as we are given. All right, so this is it. We know what we are supposed to calculate. We are supposed to calculate what? The first area moment there, but this is it. I explained in the previous case, just because I want to explain much, I'm just going to remove this. Just going to write this here, because the way that I want to explain, I need this information. I need the diagram to be closer to me. All right, to be closer to the screen, I mean. So remember, we've got our x as 3 over 2, the square root of y plus 6. That is what we got from our question. All right, so I want this diagram to be very, very close to my explanation so that you understand me. So this is it. In order for you to have the first area moment, from your formula, do not worry about that, because even from your formula sheet, you're not given that. They just give you the formula for calculating the center of pressure. The center of pressure is equal to the second area moment, which is the integral of r squared dA with our limits a to b over the first area moment taken from A to B, the integral of RDA. That is what you're just given from your formula sheet. If you check from your formula sheet properly, that is what you are just given on page number 5. All right. So now, no, it's supposed to be page 6 of your formula sheet, yes. So now from this, you are the one who's supposed to understand. This one is your first area moment, and this one is your second. So here we're dealing with the first, and like I said, this is our first, and this is our second. So second area moment over first area moment. So the question there needs us to calculate the first area moment. We need to say this is the formula for the first area moment, all right? So that's 5.42. So 5.42. The first area moment, we can just write it in short. That's the area moment with respect to x, that is about the x-axis, all right, which is given as the integral of RDA with our limits a and b, of which you're supposed to write this as c and d. From the y-axis, I usually write them as c and d, but that is what you have in your formula sheet. I do not want you guys to have a confusion, so that because the formula sheet is the one you have that you have at the end. So you just need to interpret your formula sheet. All right, no problem. I said the r there is simply the distance that we are taking from what? From the x. We're talking about x-axis there, about or around the x-axis. So this is the distance from the x-axis, and the distance from the x-axis is given by what? Is given by y in this case. So that is going to be the integral of y, the y values that you're going to have, all right, from A to B, meaning to say we are now substituting after that. But as for now, we are still having it in form of a formula. So I'm just going to write as A and B. Okay. Now, dA, it's an expression for area, this one. This is what you have in the final exam. So you need to interpret now, what does this dA means? dA is the expression of area. Remember from our normal area, the formula for area, because we are talking about the area that is going to affect with respect to y. All right, this is not area for x. The area moment is about x, but we talk about this given the limits for y in this case. All right, on our normal formula for area, we all understand that the expression for area, our normal expression actually for area is given, y is given as the integral of x dy. That is what we have from A to B, isn't it? Which will be from C to D if you talk about proper limits, if you want to have that. Meaning to say, this is the area of a normal shape, a normal part that is affected about the y. But because this is taken into two, like we've got here, this half and another half there, this formula is going to be given as 2x. Instead of being given as xy, it is going to be multiplied by 2y, because we have got two shapes that are the same. This area here and this area on this other side will be equal. We could have calculated this area this side. We could have used the point here. Remember, this is 3 minus 2. On this side, it was going to be minus 3 minus 2. Meaning to say we could have used this shape, this one. We could have worked this side here. But instead of us working this side here, instead of us calculating this area here of this side, and also come back this side and calculate the area here, that we know it is the same. Instead of us having that, to say we calculated something before and we want to do the same thing. Though the equations will be different, but at the end, the areas will be the same. The other one is going to carry a negative. The other one is going to carry a positive, but the area is the same. So instead, we have to multiply that by what? By 2. So this dA representing your area expression is going to be given as 2x with respect to y. The 2x is for two areas that we're talking about. The area on this, the area on here, multiplied by 2. That's the idea there. Are we together there? All right. So we're done. Once we are here, we're done. We just have to fill in. All right, let's fill in everything that we are given so that we can calculate our area moment. What is it that we are given here? We have to substitute x. So you can even take out the 2 here out of the integral if you want. So you're going to have 2, the integral of a and b. Like I said, these are the limits that you're given since we're talking about with respect to y. So these are the limits for y. Our tank or our retaining wall is taken from where? From -2 up to -6. That is where it plays a role. You are not starting from 0. This is where it is 2 meters below. So it is starting at what? -2 up to -6. So that's -2 being our upper boundary, the one on top, -2, the minimum, -6. Then the 2, remember, is the one that we took outside. So we are remaining here with the y times x because we have taken the 2 outside. So our x is given as what? Remember, our x is an expression that we got previously, this one. 3/2, the square root of y plus 6. So there we have got 3/2. Let me not open the bracket because this one is a product. All right, sorry for that. Sorry for that, guys. I just want to remove this bracket here. So this is 3/2, the square root of y plus 6, like this. This is what we are given with respect to y. All right. This is where we are. Okay? This is where we are. At this stage, we need to integrate, but we have to think of finding a simpler way before. So you can even take out this constant again, 3/2 out. So if we take this out, it's going to be 2 times 3/2. So if you multiply this, you're going to get a 3. So that will be 3, the integral of, so we are going to integrate y times the square root of y plus 6 like this with respect to y. That's it. That's the idea there. That's it. We are done. So let's integrate now. How can we integrate this? That's the question now someone is asking. How can we integrate this? This is what we have. We can choose to use the substitution method because here it's going to be difficult a little. We can't do anything here, right? We can't expand this. So it's going to be difficult for us to integrate direct. But we can prove, we can use our substitution method. I want us to get back to our substitution method. Remember, we had that in our N5. So here we want to integrate, all right? We want to integrate y times the square root of y plus 6 with respect to y. Okay, let us just put this aside. So this is what we have here, okay? Using substitution method, I can just let the y plus 6, which is this one under the square root, is going to be a little bit easier there. So let u be equal to y plus 6. So we have to find, because we need to remove this, so we need to find dy, and thus we have to find the derivative of u with respect to y, which is going to give us a 1, and that's a 0 there, which is a constant. Remember, it's a 0. So that means in this case, our du is equal to dy. That's dy is equal to du. They're just the same. Okay, so what's the purpose? Okay, we'll see that. The purpose is that if we are to substitute here, we were going to have this as the integral of y times the square root of this y plus 6, which is said u is equal to y plus 6 times dy, which is our dy is equal to what? Is equal to du. But if you check, your question now is not making sense. Why? We cannot integrate a condition. This is not this is not a condition like what we had in derivatives, where we can we had that like those partial derivatives. No, where you differentiate y and you leave x at that moment. No, on integration you don't have that. So we can't have an integral that is happening between y and u at the same time here. So what do? We have to go back where we introduced u, because it's with respect to u. So we have to make this y the subject in terms of u so that we can remove this and substitute with something that carries what? U, because remember we say this is now to be integrated with respect to u. So it means from this u minus 6 like this, u minus 6 is going to be equal to y. So where we see y, we are going to use u minus 6, all right? Y is equal to u minus 6. Wherever we see a y, we are going to substitute with u minus 6. Okay? Is this going to make sense? Let's put it here. Let's put it here and see. This is equal to, the limits, don't worry about them. We're going to talk about this later on. The integral of y here, which is u minus 6. Okay? Times the square root of u, which is the same as u to the exponent of a half. Remember the square root of u. Why bringing it to the exponent of half? So that at least we can expand this, integrate. All right. So this is what you're going to have. We're going to have the integral of, expand this. That will be u to the exponent of, we are multiplying, that's a 1. So 1, that's u to the exponent of 1 times u to the exponent of half. You're multiplying there. So you add the exponents, 1 plus 1 over 2, which will be 3 over 2. You multiply minus 6 and u to the exponent of half. That's minus 6 u to the exponent of a half. This whole part here is supposed to be integrated with respect to u. All right, so this is it here. At this stage, it's up to you. I want to explain two things that you need to understand here. It's up to you at this stage. One, what am I trying to say? It's either you are going to integrate with respect to u. Later on, after you are done with your integration, you substitute wherever there is a u, you substitute what? Y plus 6. Okay? Or instead of doing that, because already you see that it is going to be a complicated thing that you have to substitute. Remember, guys, y plus 6 is an expression. U is a single term. It's just u. There is no plus this or minus this. So it means I can take advantage of that and have the limits for you. So where do I have the limits for you? Remember, we said u is equal to y plus 6. So we can take the limits that we had before for y. Before here, we had the limits for y. All right, we had the limits for y here. Where y is at what? At negative 2. We have to substitute because these were limits for y here. The limits for y. Now we are talking about u. So we need the limits that will correspond. So we want the value that will correspond if y, this is a value for y, this one, with for y. So if y is minus 2, what is the value of u? That is what you are simply having there. If y is minus 2, what is the value for u? Minus 2 plus 6, that's a 4, right? That will be a 4 there. If you add, so you're going to get a 4. So meaning to say, for in place of y, now in terms of a u is 4 if y is minus 2 plus 6, because u is equal to y plus 6. So you simply add. So you get a 4. So here we can't use any limit because there is y and u. So we are not going to put any limit. I'm going to put the limits here. So this will be at 4. Remember, we said these are now limits for what? For u. Where y was minus 2, u is 4. So you place where y was. Now you put what? A 4. You go back, you do the same thing. Where y is minus 6, what will be the value of u? You substitute back here. If y is minus 6 here, what are we going to get? Minus 6 plus a 6. What do we get? That's a 0. So mean to say u is equal to 0. So that's the limit for u at that moment. U is going to be what? At 0. So the u here is at 0. So that's 4, 0. So this is what we are now having on our integral. Guys, it has changed. It has changed. Everything has changed. Unless you want to do this integral, then you substitute back y. You can maintain this part that you had here. You can do that. I'm not saying it's wrong, but you can take advantage of this type of equation instead. So meaning to say our question has changed now. It is going to be 3, the integral of our limits from 0 to 4. What are we integrating? We are integrating this u to the exponent of 3 over 2 minus 6u to the exponent of a half. Everything with respect to u. These are change of limits. You're supposed to also think about these guys, okay? N6, okay, let's think about this also. We talked about this in N5 anyways, but we need more in N6. So let's integrate. We are done. Let's integrate. 3, we integrate u, we add a 1 as usual. If we integrate, we're going to add a 1. So that will be 3 over 2 plus 1. That will be 5 over 2. So you're going to have 5 over 2 divided by 5 over 2 minus, we do the same thing here, 6u to the exponent. We add a 1. So that will be 3 over 2 over 3 over 2 like this with our limits. Remember, these are now limits for you. That's why we are using them. These are limits for you. Okay? Be careful. Be careful there. Be very, very, very careful. So you can simplify before the limits. That will be 1 divided by 5 over 2 is going to be 2 over 5. So this will be 2 over 5 u to the exponent of 5 over 2 minus 6 divided by what? 3 over 2. That will give you a negative 4. So that's negative 4 u to the exponent of 3 over 2. We substitute back our limits as usual, 4 to 0. All right, this is what I was explaining now. To say, if you wanted to use these old limits, the previous limits, these ones that we had here, the limits for y, if you wanted to use this, guys, this is what you're going to do. You are going to integrate like this. Like here, we have integrated. Remember, we no longer have the integrals and we have integrated. So you are going to take this back now. In place of u, you bring back what you had in terms of y. Remember, we said u is equal to what? Let u be equal to y plus 6. So it means we are going to write this as, I want you to have to know this. Okay? You remember u is y plus 6. So you're going to write this as, we have integrated. So now you're going to have this. You are now substituting. In place of u, you substitute with what? That expression for u, which you said what? Y plus 6. So this is going to be 3 into, that will be 2 over 5. So here it's going to be 2 over 5, like this, into u, which is what? Y plus 6, like this, to the exponent of 5 over 2, minus 4 into u, which is y plus 6, to the exponent of 3 over 2. But the limits, since we have gone back to the y that we had originally, the limits are going to change, because when we had y here, the limits were minus 2, minus 4. So once you bring back y, the limits has to change also. The limits has to change also. You're supposed to go back to the original one. Minus 2. So you simplify this. Just going to have the same answer. You substitute in place of y. You're going to have the same answer as this one. Here we took advantage that our expression is already in terms of y. So instead of you having this step, and even look at this step, how complicated it's an expression. But guys, if you are used to that, continue like that. Okay? Continue like that. Okay? If this one is the easier one that I'm explaining here and you understand this, use it like that. Okay? So let us substitute upper limit first. The upper limit when 4, so it's going to be 2 over 5. That's 4 to the exponent of 5 over 2 minus 4 into u, which is 4 to the exponent of 3 over 2. Upper limit always. Upper limit first minus the lower limit. By just mere looking, we are substituting a 0 here. And a 0 when raised to any exponent, it becomes a 0. So what about when you multiply it? It's just going to remain as a 0 on this part. So this is the part that we are going to simplify. So it's going to be 3 into whatever that you're going to have on this part. So I just want us to be quickly on our calculator and evaluate everything and see what we are going to have. That is the idea there. All right. So I'm just going to have this quickly. Let me share our calculator, guys. Very sorry for this. I didn't think that it's going to take long like this. Okay, but it's fine for revision, guys. This one is fine for revision. 2 over 5 like this into 4 to the exponent of 5 over 2 to the exponent of 5 over 2 like this. Okay. Minus 4 into 4 to the exponent of 3 over 2 like this. That's it. Okay. Let's hope do not miss anything there. That will be negative 96 over 5. So we are getting negative 96 over 5, of which this whole part there is a 0. So if you subtract a 0 from anything, it remains like that. So we multiply by the 3 that is outside. This will be negative 288 over 5. All right, that's units to the exponent of 3. Remember, this is the first area moment, area cubic square units. So the moment we talk about first area moment times a meter, so it will be cubic units. All right. Second area moment is from the first area moment times another meter. So it will be meters to the exponent of 4. That is the second area moment but for the first area moment, or you can even write it as a decimal if you want. You can even convert it to a what? You can even convert it to a decimal. It's a choice, all right? It's not like you are limited to have this as a whole number. You're gonna get something like negative 57.6, something like that. Negative 57.6, something like that. As a decimal, if you want, you can have it like that. Cubic units. That's it. That was your first area moment. That was your first area moment. Is it difficult? It's not difficult. It's not that difficult. All right. So if you used these ones, you're going to substitute again upper limit minus lower limit. Still, you're going to get the same answer. All right. From y values, you're going to get the same answer just like the previous case. So I want you to try and do that. You'll see that you are having the same answer. All right. So that was it. And always, if you calculate for them, this is the other thing. If your diagram is below, like if you have a diagram below the x-axis like this, if you take your diagram under the x-axis, your first area moment is going to be a negative. That's why you see your answer there is giving us a negative value. It's always like that. All right. Now this is what we are having, 5.43. Calculate using integration again the second area moment of area of the retaining wall described in question 5.41 about the water level as the depth of as well as, so there it's as well. All right. So that's as well as what? As the depth of center of pressure of the retaining wall. All right. So we need the second area moment. So as we can see, we are not going to need all this information. So I'm just going to erase these guys. But I want us to talk about the formula first so that you'll be able to understand me once again. All right. So you calculated your first area moment. Just going to write the answer because we'll need that answer. So our first area moment, we got negative 288. Yeah, that was negative 288. Negative 288 over 5 cubic meters or cubic units, but these are meters. All right. So that's as a decimal. You can also write it as a decimal if you want. Okay. But the question is, how are we going to calculate our second area moment? Okay. No problem. Let me do this. Or this part I'm just going to erase as I am going through. For now, let me just work on this part. All right. Let me just, I don't think we're going to need this part here. All right, guys, very sorry for that. This is it here. So if we are to take this condition, let us take this way. If we were to talk about this formula because this is our second area moment. That this is the formula here on top. Remember, I talked about this on top. So the formula is that it is stating that in order for us to have the second area moment, right, that's 5.43. All right, so you're going to have second area moment, second area moment. So this is what you're going to have. We are given this formula as the integral of r squared dA with our limits taken from A to B. And I explained about the r there as the distance that we are taking and from the x-axis, which means we are talking about the y there. So, but this time it's y squared. So this is going to be AB y squared. The dAs, there nothing is changing. We are still back to the same dA that you talk about, same concept to say that the area is the same for both shapes. So we multiply by 2. It's not like when you are calculating area, the 2 is there. No, the 2 is not there. It's the 2 I explained because of what? These two regions that you're talking about, this region and this region, they've got equal areas. I think I explained about that. So the area expression is not going to change. This dA is just a repetition. So this is going to be 2x, like I said before, dy. All right, we can take our 2 out of the integral, just like the previous case. So it's going to be a and b. Also, it's not changing the limits for a and b from -2 to -6 of the wall where we are having the tank here. It starts at -2. It ends at -6. All right, starts at -2. That will be y squared times. Remember, the 2 is the one that we got that we took out. So it's just going to remain with what? X. And what is the expression for X? That's where we need that X. X is given as 3/2 the square root of this. So that is a 3/2 the square root of y plus 6. So that's the square root of y plus 6 with respect to y. So again, another repetition that we talked about. You take this out, you're going to multiply. So there you ended up with a 3. So that will be 3. The integral of -6, -2 y squared times the square root of y plus 6 with respect to y. Okay. There is where we are. There is where we are. There is where we are. Okay. Still, it's going to be complicated again to integrate here. It's going to be very, very complicated. But we talked about substitution before. And this is going to work. Very, 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 it's going to work. So you're going to go back to the substitution method here. Guys, very sorry. Very, very sorry. I'm just like, there's a lot that is happening here. That's N6 for us. So we are supposed to have this. Actually, we are supposed to enjoy this. All right. So we are going back to our substitution, but I'm not going to waste much time because the substitution to be done is the same. Right? The substitution to be done is the same. U is equal to this because we still have the U. So this is not going to change. And also, you can go back to that part that we talked about the limits. Remember, we said if U is -2, if Y is -2, U is going to be 4, and the other one is going to be a 0. So we are back to the same, nothing is changing. So even here in place of Y here, last time it was just Y. This one is Y squared. And now we said Y is equal to what? Y is equal to U minus 6. So it's going to be U minus 6 squared. All right? In place of Y, we have got U minus 6. So the substitution part is not going to change. So take note here. Take note. Take note. All right? So let me just write aside. Maybe you can understand. So take note. The substitution. All right. The substitution here is the same. So if the substitution is the same, what does it mean? It means we are just going to have a continuation. The integral of, remember, we've got our 3 outside, all right? Our limits are going to change because we are now working with the U, no longer Y. So take note, this is going to change, and also this is going to change. That's where we talk about those limits in terms of U. We ended up with 4 and 0. So that will be 4 and 0 like this. So the upper limit is going to be at 4, and that's at 0. Y squared. Remember, we said y in terms of u is what? Y is u minus 6. So you're going to have u minus 6 squared. So this will be u minus 6 squared times, remember, u minus 6 is the one that is represented by what? I mean, this y plus 6 is the one that is representing u. This one, y plus, is u. So it's the square root of u. And I explained that the square root of u simply means u to the exponent of what? U to the exponent of a half. And we saw that this dy is equal to du here. Dy is equal to du. So meaning to say it's an integral that is directly for you now. This is what we are now having. So how are you going to integrate this? That is a question now. So as you can see here, we need to expand our brackets. That's u minus 6 squared. We are back to that. If you still remember, we talked about this binomial. This thing, this trinomial part where you expand. So you're going to have two brackets that you expand. So I'm not going to waste much time here. I'm just going to have this as u squared. Remember the first term squared minus 2 times the first term and last term. So it's going to be minus 2 times this, it will be 12. So that's 12u plus the last term squared, which is 6 squared, is 36. All right. But I talked about this expansion, or you can just open two brackets, expand your brackets. So this is going to be integrated with respect to u. So there's nothing there. But because of this, that we have got the u part in the bracket and another u to the exponent of half out of the bracket, what are we going to do? We have to get rid of the u outside of the bracket. So expand everything by this u. So that will be, remember, the 4 and 0 are the limits for you, the ones that I talked about previously when we had the change of limits here. From this u, we substitute the values. So do not panic about that one. When I said you only use these ones if you are integrating with respect to u, and your answer is and you are going to leave everything in terms of u. So let's expand this u to the exponent of half times u to the exponent of 2 times u to the exponent of half. You add the exponents, so that will be u to the exponent of 2.5 is 5/2. Yeah, that's 5/2. Minus 12, you multiply again. This is 1. So you're going to add 1 plus a half. That's 1.5, which is 3/2. So 1.5 is same as what? 3/2. Okay. We do the same thing. 36 and u to the exponent of half. That will be plus 36 u to the exponent of a half. You integrate this with respect to u. So this is just a normal integral. There is nothing special here. Nothing special. Is there anything special here, guys? Nothing special. We do not have any law. We do not have any formula. We are just back to our normal integrals. So we're just going to integrate everything. Remember, on your integrals, you add 1, then divide. So in actual sense, you are supposed to add 1. You get u to the exponent of 7/2 like this. You divide by 7/2. So it's like this: 1 divided by 7/2, it gives you 2/7. If you divide this 1 divided by this 7/2, it gives you 2/7. U to the exponent of what? Of 7/2. So instead of you substituting those, that expression for you that you had before, no, you are not going to sub, because already the limits here are changed to be for what? To be for you. So you leave everything. You just have to substitute your limits for you as they are. All right, let us move on to the other part of our integral. We integrated the first part. That was the integral of the first part. We move on to this. We do the same thing. Negative 12 u to the exponent. We add a 1 here. So that will be 5/2. 3/2 plus 1. That's 5/2. So it's going to be 5/2 over 5/2 like this. So if we divide at the end, what are we going to have? Negative 12 divided to 5/2 is going to be negative 24/5. So that's negative 24/5 u to the exponent of 5/2. So that's it. We have integrated this part. We move on to the last one here. That's 36 u to the exponent, we add a 1. So that will be 3 over 2. A half plus a 1, that's 3 over 2. So it's going to be 3 over 2 over 3 over 2 like this. So it's 36 divided to 3 over 2. If we divide 36 and 3 over 2, what are we going to get? That's a 24, direct 24. So that's 24 u to the exponent of 3 over 2. Remember, we still have this, to the exponent of 3. We have integrated everything. And with respect to u, our limits are as follows for 0. So you're going to substitute upper limit minus the lower limit. And this gives us our second area moment. All right, so that's it. So this will be 3 into, we substitute our upper limit in place of u, you're going to substitute a 4. So this is 2 over 7, 4 to the exponent of 7 over 2 minus 24. So this will be minus 24 over 5. So that's 24 over 5, 4 to the exponent of 5 over 2 plus 24 into u, which is 4 to the exponent of 3 over 2. So that's it. We have substituted, in this case, your upper limit. Then what are you going to do? You must subtract when you substitute the lower limit. So this will be like this. You're going to have minus our lower, by just looking into the lower limit, which is a 0. That's a 0 to the exponent of any number, which is a 0, and a 0 times any number, that's a 0. So meaning to say on this one, there's nothing that you're going to get there. All right. So there's nothing on this one, just a 0. So that's it. Upper limit minus the lower limit. Once you are there, you are done. Just have to simplify further and find your final answer, which is the resultant. So if you do this properly, you are going to get something on this part is going to be 3 times 2624, like this, everything over 35. So if you multiply this, that will be 7872 over 35, which is, as a decimal, is going to be 224,914, which is meters to the exponent of 4. Remember, this is the second area moment. All right, that's it. That's how you're supposed to have this. You're done. Okay, you're done. But the question needs us also to determine, remember, it was also as well as, it's not just determine this, as well as what? The depth. We also need here as well as the depth of the center of pressure of the retaining wall. So the depth of center of pressure is the one that I talked about here, that the depth of center of pressure from our formula is the second area moment over the first area moment. We calculated the first area moment here, remember? Sorry, for that, we got negative 288 over 5. So you're going to divide this area second over first. So our second is the one that we have just calculated here. What we have here. Okay, guys, this is a lot. Let me just reduce. All right. Yeah, I think you can properly see this. All right, this was our second area moment, this one. Okay, so just take a closer look of your stages. Make sure that you understand every stage. All right, so that's it. Okay, I hope it's clear, that one, guys. Okay, so now let's find our final answer. Therefore, y second bar is gonna be, like I said, it's the second area moment over the first area moment. So the second is this one that we just calculated. I'm just gonna take this exact value. It's best to use exact values. You can use a decimal, it's fine. 7872 7872 over 35. These are meters to the exponent of 4 over the first area moment. Remember, it was negative 288 over 5. All right, cubic meters. So that's it. We can have our second, the depth of center of pressure, which is in this case, because our diagram was below, we were taking it below the x-axis, like we are taking our diagram, consider the water surface as the x-axis. We can have it above, like we can have our diagram drawn above. On that condition is different. You're going to get positive values as because it is below. The shape is below. We took the x-axis as our water surface. So it is going to be a negative. That's why we see a negative on the first area, more even on this one. So that will be negative 3,905 to 3 decimal places, all right, in meters. Remember, these are cubic meters. Into this, there are 4 of them. You just remain with 1. So it is meters. So this is simply 3,095 meters that we have, all right? But because it was taken below, we are taking the water surface as our x-axis, which means our diagram is supposed to be starting from the x-axis going down. On that condition, all answers, they are going to be taken as what? As negative values, all right? On another method, on another way, your answers will be taken as positive. So take note with the method that you understand, all right? But as for me, I'm just going to explain about this. I think this is the easiest one that we can all understand. And also do try to revise, to revisit also your basics of integration. Because as you can see, once you know the concept, the rest is integration, as you can see. So you have to go back those substitution method, change of limits from your N5. That's it. You are done. So that's it, guys. Shall meet again from Meson African Motives.